Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Iman Firdaus. I'm going to be explaining about NoSQL databases. NoSQL databases have become very popular. Big companies rely on them to store hundreds of petabytes of data and run millions of queries per second. But what is NoSQL? NoSQL database and how does it work and why does it scale so much and better than traditional relational databases? Let's start by quickly explaining the problem with relational database like MySQL, MariaDB, SQL Server, and alike. These are built to store relational data as efficiently as possible. You can have a table for customers, orders, and products linking together logically. Customer places an order, and orders contain products. This tight organization is great for managing your data, but it comes at a cost. Relational database have a hard time scaling. They have to maintain these relationships, and that's an intensive process requiring a lot of memory and compute power. So for a while, you can keep upgrading your database server, but at some point, it won't be able to handle the load. In technical terms, we say that the relational database can scale vertically but not horizontally, whereas NoSQL databases can scale both vertically and horizontally. You can compare this to a building. Vertically scaling means adding more floors to an existing building, while horizontal scaling means adding more buildings. You intuitively understand that vertical scaling is only possible to a certain extent, while horizontal scaling is much more powerful. Why do NoSQL database scale so well? Well, first of all, they do away with these costly relationships. In NoSQL, every item in the database stand on its own. The simple modification means that they are essentially key value stores, which each item in the database only has two fields, a unique key and a value. For instance, when you want to store product information, you can use the product's barcode as the key and the product name as the value. This seems restrictive, but the value can be something like JSON document containing more data like price and description. This simpler design is why NoSQL database scales better. If a single database server is not enough to store all your data or handle all the queries, you can split the workload across two or more servers. Each server will be then responsible for only a part of your database. To give an example, Apple runs a NoSQL database that consists of 75,000 servers. In NoSQL terms, these parts of your database are called partitions. And it brings up a question. If your database is split across potentially thousands of partitions, how do you know where an item is stored? That's where the primary key comes in. Remember, NoSQL databases are a key value stores, and the key determines on what partition an item will be stored. Behind the scene, NoSQL databases uses a hash function to convert each item's primary key into a number that falls into a fixed range, say between 0 and 100. This hash value and the range is then used to determine where to store an item. If your database is small enough or doesn't get many requests, you can put everything on a single server. This one will be then responsible for the entire range. If that server is becoming overloaded, you can add a secondary server, which means that the range will be split in half. Server 1 will be responsible for all items with a hash between 0 and 50, while server 2 will store everything between 50 and 100. Theoretically, you've now doubled your database capacity, both in terms of storage and in the number of queries you can execute. This range is called key space. It's a simple system that solves two problems, where to store a new item and where to find the existing one. Now, all you have to do is calculate the hash of an item's key and keep track of which server is responsible for which part of the key space. Now, in this example, the range of 0 to 100 is a bit small. It will only allow you to split up your database into 100 pieces at most. So, real NoSQL database have much bigger key spaces, allowing them to scale almost without restriction. I think that's all from me. Thank you.